Tonight, the story behind one state's extreme weather. Minneapolis can be 40 degrees below zero in January and 100 degrees in July. What creates this massive extreme gap? To understand these extremes, we look at continental climate mechanics where immense landmasses heat and cool rapidly, far removed from the thermal stability of vast salty oceans. Minnesota sits in the deep heart of the North American continent. It is thousands of miles away from any major ocean body. Water has high specific heat capacity, meaning it absorbs vast solar energy without raising temperature significantly, serving as a massive global temperature stabilizing battery. Oceans act like giant heat moderators for the coastal air. They keep temperatures mild through both the winter and summer. Minnesota has no such buffer to soften the seasonal change. In January, the state is often gripped by the polar vortex, a large-scale cyclone of extreme cold centered near the Earth's poles, periodically dipping southward. Without water to hold on to heat, the land cools fast. In winter, cold Arctic air rushes south without any resistance. That air is dry, dense, and frigid from the North Pole. Consider the record temperature drop in January 1996 in Tower, Minnesota, where the thermometer plummeted to a staggering minus 60 degrees Fahrenheit. If you find this explanation of weather fascinating, please like this video. Summer brings a totally different problem for the state. In summer, intense sunlight bakes the soil, which radiates heat back without cloud cover to absorb it. Warm, humid air flows north from the Gulf of Mexico. Because Minnesota is landlocked, it gets trapped by this heat. Without mountains to force air upwards or block these moisture surges, extreme dew points often exceed 70 degrees during heat waves. What's the most extreme weather you've ever experienced in your state? Tell us down in the comments below. The jet stream also plays a huge role here. Scientifically, the jet stream is a core of strong winds roughly 30,000 feet up, steering weather systems based on temperature gradients and the Coriolis effect. It acts like a highway for high and low pressure systems. When this flow stalls, Minnesota experiences either prolonged droughts or severe storm sequences, like the historic flooding of the Red River back in 1997. Minnesota sits right under this busy intersection. This creates constant swings as different air packs pass through. So it is a mix of geography and wind patterns. The land lacks the moderating power of a nearby ocean. That makes Minnesota a place of truly wild weather swings. Thanks for watching. Subscribe to SkyCast for more daily updates on fascinating weather phenomena.